In 2017, a 23-year-old woman suffered a postpartum hemorrhage after delivery of a healthy baby boy in rural Rwanda. She required a transfusion to save her life, but the closest blood bank was hours away over poorly maintained surface roads. Until recently, her prospects for survival would have been bleak. But on this day, her life was saved by a tech-driven health solution that has the potential to revolutionize the way we deliver medical care to areas where it is needed most. Within half an hour of doctors sending a text message, a drone appeared in the sky and dropped off the supply of blood needed to save this patient's life. She recovered and left the hospital days later with her healthy baby boy. The age of medical drones has arrived. With the help of a for-profit startup called Zipline, thousands of medical flights have occurred in Rwanda and Ghana, carrying blood products, medications, and other medical supplies to areas difficult to access by standard roadways. Programs in other countries have used drones to deliver food, water, and other supplies for humanitarian aid. And while the use of medical drones has flourished in third world countries and remote areas, this technology has potential to vastly improve care delivery, even in regions where healthcare access is seemingly easier to come by. Vast portions of America are sparsely settled, with people living far from urban medical centers. Weather conditions often render existing delivery vehicles impractical or hazardous, including icy or poorly maintained roadways for ambulances, or poor visibility which stymie the flight of helicopters. Traffic conditions impose dangerous slowdowns in delivery. Imagine, for example, trying to transport a blood sample through Midtown Manhattan during rush hour. Drones could offer effective alternatives in these situations. Drones also have cost advantages. A 25-pound drone carries supplies less expensively than a 2-ton ambulance or a 3-ton helicopter, and there's no need to pay an employee to travel with the delivery. Drones also offer potential economies of scale. A single remote pilot, for example, can manage occasional flights across multiple areas, rather than having conventional pilots available and waiting at each transport hub. Drones could also mitigate safety issues that arise with traditional modes of transport. People can be injured or killed transporting patients or medical supplies in adverse conditions. Where current modes of transport are hazardous, a lost drone is far less expensive than a lost helicopter or lost airplane, and minimizes the incalculable risk to human life. Several advances to medical drone technology are in development. The TU Delft ambulance drone has been designed as a prototype integrating a cardiac defibrillator with two-way video communication. In the case of a cardiac arrest, emergency services could deploy the drone to the patient, and bystanders would be instructed on how to perform CPR and use the automatic defibrillator until emergency services arrive to take over. Google has also filed a patent for a similar drone that would bring medical aid to people in distress, designed to arrive to the scene before the ambulance. Hero Technologies is developing an advanced telemedicine drone, which can be deployed with a customized medical kit, two-way video conference capability, and may be useful to reach areas that health rescue personnel may not want to enter immediately, such as areas with chemical or infectious hazards. And the startup eHang has signed a contract with Lung Biotechnology PVC in the US to develop up to 1,000 units of the world's first autonomous drone capable of transporting a human. The purpose is to automate transportation of donated organs to people all over the country. What then are the obstacles to adoption? Current regulations generally prohibit a drone from flying past its pilot's visual horizon line. Another key challenge is establishing a workable traffic management system in the national airspace. There are fears of mid-air collisions involving drones and manned aircrafts. Other hazardous situations include flying over people or at night, with concerns of drones striking fixed objects or falling onto people below. These types of concerns are not merely theoretical. In December of last year, a nearby drone caused the shutdown of London's Gatwick Airport for more than 24 hours, as a deliberate drone incursion into nearby airspace raised safety concerns. Additionally, the widespread use of drones may lead to breaches of privacy. Most small drones are built in China, raising worries that command and controlled software could be programmed into the drones at installation to collect and transmit reconnaissance data without the knowledge of drone owners, operators, or clients. Despite these obstacles, drones have the potential to be reliable medical delivery platforms for microbiological and laboratory samples, pharmaceuticals, vaccines, emergency medical equipment, and even patient transport. The next steps include aggressive research initiatives into the areas of safety, industry expansion, increased public awareness, and participation. On April 19th, the University of Maryland Medical Center received the first drone-delivered organ used for transplant. The patient was a 44-year-old man who had spent 8 years on dialysis before undergoing his renal transplant. With further development of drone technology, these types of firsts will be duplicated and enhanced, continuing to provide meaningful value, increase timely healthcare access, and enable widespread benefit to real patients. Thank you for your time.